Hello and welcome to UNI.MINDS Festival. My name is Jana and I'm really delighted to be hosting this workshop that is part of UNI.MINDS Festival. The mission of the festival is to strengthen the industry and academia partnership and grow the innovation community in Slovenia. You can find more information about the whole festival at the website of the festival and also in the Whova platform, and you will find the links to both in the chat box. We started right on time, and today's workshop will be focused on trends and challenges in extended reality, and it will be led by Dr. Jože Guna. Dr. Jože Guna is an assistant professor at the Faculty of Electrical Engineering at the University of Ljubljana. His area of research focuses on internet technologies, multimedia, and IPTV systems, with special emphasis on user-centered design, user interaction modalities, user experience design, including gamification. And currently, he's involved in really a number of projects that are really interesting, focusing on development of intuitive user interface for elderly users of e-health applications. This workshop will be interactive. We really encourage you to ask questions. You can use the Zoom chat and we'll try to answer them during the workshop or at the end. And you can, if you want, you can download these beautiful backgrounds that we have, and you can find the link to them in the chat. And for the start, this is it. I will give now the word to Jože. So Jože, please, the floor is yours.
Thank you, Jana. Just let me share the screen. Okay, so thank you for these kind words of introduction, and also I would like to welcome you to this workshop. My name is Jože Guna, and today I would like to talk about extended reality technologies and present some current trends and challenges that still exist within this interesting field. But first of all, let me just check if this multimedia Zoom application is working properly. So Jana, can you see and hear me well?
Yes, we do. We hear and see everything. Let's go ahead.
Great, thank you. So in the next 45 minutes or so, I would like to put some light onto current events and developments within the extended reality technologies, and also show some applications. Basically, it would focus on applications in our laboratory in this field. But first of all, let's see some intro movie.
Dad picked that name because it sounded like a superhero's alter ego, like Peter Parker or Bruce Banner. But he died when I was a kid, my mom too. And I ended up here, sitting here in my tiny corner of nowhere. There's nowhere left to go. Nowhere. Except the oasis. A whole virtual universe. People come to the Oasis for all the things they can do. But they stay because of all the things they can be.
Can you feel this?
Yeah. It's the only.
So this was a short clip from the movie Ready Player One, which shows a future how the technologies within extended reality could influence our world. I hope it won't be that way, but I think these technologies have a great impact on a number of domains, starting from education, entertainment, industry, and others. And I think they will play a really important role in the near future. So today I would like to talk about XR landscape, so extended reality landscape, and show some key technologies within augmented and virtual and mixed reality systems, show some key examples of content and applications, and at the end, try to, let's say, sum the area up with current trends and also challenges, industrial challenges, as well as um, technological challenges and also scientific challenges that still needs to be solved in order to make these technologies usable and accessible for basically everyone. Also, discussion is very much welcome. You are most invited to write your comments and questions in the chat, and I'll try to answer them at the end of this workshop, this keynote. I come from the Laboratory for Multimedia within the University of Ljubljana, Faculty of Electrical Engineering. This is a, let's say, a short sneak peek into our laboratory. It's called a demo room, where we showcase our solutions and technologies and also do user experience tests. And also this is an example of content. Actually, this is available as a 360 panoramas on Google. Under this address, you can find us and peek into our lab. And speaking of 360 panoramas and videos, this is an important content which is greatly suited for VR consuming, and we'll highlight it also within this talk, some challenges related to 360 videos within VR. Just one slide about who we are, what we do. So our main activities, of course, are education, also research and development. We do a lot of industrial cooperation and projects within industry, and also put this knowledge within education and our projects. We do professional trainings. Also, this workshop is in a way part of these trainings. And also we include students within our projects because we think young minds have great perspective on many things and should be included. Within the scope, what we do is complete multimedia and XR application development. Also, we do a lot of user experience design, research, evaluation, and we help our partners improve their systems, whatever they may be, from applications to physical products. We do multimedia production, so applications without content are quite useless, so production is important, like videos, audio, and stuff. And we do also extended reality multimedia production, which is a special case of this because it's omnidirectional. It's different from the traditional cinema. This is just a short intro to our lab, some of the activities, but now to the main topic, forms of reality, which will be highlighted in today's talk. So basically we know, or we, let's say, divide our extended realities into VR. VR stands for virtual reality. And this implies virtual environments which are totally created by the computer and can be, and thus the users can experience basically anything, and also experience, for example, content that usually cannot be experienced. For example, how to travel within one's body and experience the blood flow, or how to visit Mars. So basically, we can show in 3D experiences that are otherwise inaccessible. And for this reason, VR is very, very much suited for education, also tourism, also entertainment and other fields. On the other hand, end of the spectrum, we have augmented reality and mixed reality technologies. They are quite similar in purpose, but there is a slight difference between them. They're usually experienced through special glasses or a camera or a laptop or mobile phone or a tablet PC, where the real environment is superimposed with digital objects. Also, they are called digital holograms. And the main difference between those two is that in the case of mixed reality, by the way, this is the term coined by Microsoft about 4 or 5 years ago when the HoloLens device came out. In the case of mixed reality, these digital objects are actually aware of the space around us, whereas in augmented reality, they are not. So in mixed reality case, you can put objects on a desk or maybe on the floor, and they are aware of obstacles in the real environment and act as real objects. So they look and feel like real objects. Of course, you cannot feel them. That's the only limitation for now. But otherwise, you can put, for example, if you're building a new apartment, you can try how a new piece of furniture made from IKEA or some other store would look like exactly in your living room. So this is also very much suited for education and industrial applications. And what is RR? Of course, we cannot forget on real reality, which we're living in, and should not, let's say, live too much in virtual environments. More scientific explanation of these terms has been coined by two famous authors, Milgram and Kishino. In their paper, they have, let's say, divided the extended reality landscape into the real environment on one hand, which is augmented with augmented reality, and on the other hand, complete virtual environment, which is shown in virtual reality. Also, these two realities can be mixed. For example, modern headsets like from Oculus or Valve or also some other companies also include cameras, and through these cameras, the real environment can be shown within the virtual space, and the users can be, although they are in VR, they can explore their real environment. So basically what I'm trying to say is that both realities, virtual and mixed reality, are being mixed within the purpose, and also very much interesting applications can be made in this way. A short introduction to this technology. Here I have the famous hype cycle curves from Gartner. If we look at them a few years ago, from 2017, we can see that virtual reality can be seen as a mature technology, and in a way it is, because it's accessible and it's really cheap and it's quite good enough, and you can try it and buy it in basically every electronic store, whereas augmented reality is just coming out and maturing. And then if we skip another year to 2018, we can see that VR is almost ready, almost, I would say, but augmented reality is still lingering here. And then if we skip to this year, yeah, so here, and also VR is shown as a trend here. So as immersive experiences. So here is where VR is hidden. And if we skip another year to 2020, because the 2018 was exactly the same as this one, we can see that there's no VR, AR, MR here, and the question is, where are they? I would say they are deemed mature technologies, and there's a chicken and egg problem with all these new technologies, is that when we have, let's say, suitable devices which are good enough in a technological way and accessible in an economic way, we need content and applications. So at the moment, the real battle is for quality content and quality applications. And if we look at this landscape, we can see that the whole VR and XR or AR industry is really huge, from the companies that make devices, so the technology which enables us these experiences, to distribution, and to companies that make content, so they make experiences. And the whole value chain is very, very much important. And I think here are lots of new opportunities for also business. There are several estimates, but the whole market is deemed several $1 billion or more of value. So this is one of the key technologies for the future, I would say, and that's why we are talking about this now. If you look at the recent XR history, so which I think are the key devices that marked the era, I would say that in the case of augmented and mixed reality, this would be Google Glass, a device which was very basic in a way, but they have shown, the Googles have shown by this device that this technology can be miniaturized in this way, that it's usable and accessible and allows us to augment the real environment with digital objects. So this, I would say, is one of the key technologies which led to modern AR and mixed reality devices. On the other end of the spectrum, I would emphasize Oculus Rift Development Kit 1, which was launched as part of the Kickstarter campaign in 2014, I think, and soon became one of the most successful Kickstarter stories, because until up to that time, there was no, let's say, mature enough VR device that would be good enough and cheap enough for the broad audience. And here the revolution was that they included in Kickstarter, in this device, really simple and accessible technologies. Basically, this is in a way like ski glasses with a mounted display from an accessible phone. In this case, this was a display from Note, from Samsung, and they added very clever inertia sensing for orientation, and also lenses. And in this way, one could experience VR in a quite technologically quite well, with a good experience. So, but this was a start, and this was, let's say, in 2014. And from that, we have, in those, I would say, 6 years, a lot of new devices came out on the market, which are also freely accessible at the moment. And on the one end of the spectrum, we have VR with Oculus, now Facebook devices. The moment Rift S is the latest one. And we have also devices from Valve and HTC. So Valve Index is one of the most, I would say, technologically advanced devices at the moment. And in the gaming area, we have Sony PlayStation VR, which is one of the leading, actually the only one gaming VR device. It's also commercially successful. On the other hand, that's devices that are accessible for the mixed reality are not that many. Actually, I would emphasize only 2 of them. One is Magic Leap device, which is a really cool device, but now the company is in a bit of trouble. And the other one is Microsoft HoloLens, which just where Microsoft just released the version 2 of this device. And then we also have Windows mixed reality VR headsets. In the middle, we have the plain old, very much cheap and accessible Google Cardboard, where a phone can be put in. A more fancy version of it was from Samsung, where the whole case is of much higher quality with glass lenses. And also here, the phone is needed to operate. And in the last year or so, also completely mobile and standalone devices came out. Maybe the most famous ones are Oculus Quest 2, 1 and 2 devices, where no phone is needed and also no wires are needed. So this device is completely standalone and offers unprecedented level of, let's say, freedom of use, which is very, very much important for user experience within VR. So maybe this just for the short introduction to the field. If we move to the VR headsets, so what makes VR special that it is? I would say the key component is hidden under the acronym HMD, which stands for head-mounted display, which is actually the headset, which includes all the displays and so also speakers and sensors for movement and control. And of course, what's most important is video and then also audio quality of the presentation. So basically pixels, we don't want to see pixels, we want to see a great picture. And also interactions are very much important. So if we move our heads within the VR space, we also would like to see instant refresh and change of environment accordingly to our movements. And for this reason, tracking systems are very much important. So these are one of the key systems within the VR, let's say, system, which enable tracking of the user, enable rotations, and also translation. So how we move within the real space, and this movement is then translated into the virtual environment. And this should be done quickly, because latency is one of the key, let's say, factors within user experience within this system. And if this disparity between real environment movement and change within the virtual space is too long, not only the experience is bad, but other adverse effects can be detected. For example, one of the most notable effects is VR sickness, where users can get really, really sick. So like motion sickness, like you are in the car or maybe on the boat. And all of this is closely connected to user experience. So user experience is very, very much important within VR and AR devices. If you look at the typical components of the VR head-mounted display, here's the, let's say, breakout of the Oculus Rift CV1. We can see that it's quite a complex device, but has several distinct features. One of them is, of course, or are displays. In this case, there are two separate displays, one for each eye. And here are different trends nowadays within VR devices. Some of them have one big display, some of them have two smaller displays. Maybe the biggest advantage of small displays is that they can be moved, and thus the inter-pupil, so inter-eye distance, can be adjusted. And this is also important for your comfort and user experience. There are lenses, because these displays are really closely mounted to your eyes, and lenses are important so that the field of view is correct for the user, and electronics that that transforms the image from the computer to these displays, and also tracks the movement of the headset and thus the movement of the user within real environment, and translates this movement into the virtual environment. What's also important are interactions, and for this reason, two typical interaction types are used within VR, and one is with this special controllers that look really strange, maybe in the real environment, but can be transformed in almost anything in the virtual one. And also free hand interactions are also possible at the moment without any controllers. So these are the basic components. Of course, this headset cannot be used as a standalone device. It needs a computer, and this headset, in a way, acts as an extended, very much sophisticated monitor. Tracking. Tracking is very important within VR because it allows movement of users in the virtual space. It allows rotations when you rotate your head, and also movement like translations when you move, actually walk within your real environment, and these movements are then translated into the virtual one. There are, let's say, several technologies used nowadays. For example, the devices from Valve and from HTC use laser tracking and have such base stations that emit laser signals, which are caught by the headset and controllers, and then calculate precise location within the real environment. And this is done like more than 100 times per second, and to the precision of less to a few millimeters in a way. And the other let's say, way how to track the users is by using cameras, either infrared cameras or RGB cameras. And this is used, for example, with Oculus Rift CV1 device, was this IR camera system was used. And then there are also two very much important terms which should be explained here. And these are, under this DOF stands degrees of freedom. Basically, we have 3 degrees of freedom or 6 degrees of freedom. And if the systems only allow 3 degrees of freedom, it means that they only allow rotations of your head, basically. But if they allow 6 degrees of freedom, you can also walk and move within the space, and all modern VR systems allow this freedom, and this allows complete freedom of movement. It's very, very much important. It should be precise, should be fast, and it shouldn't have any occlusions, and shouldn't make mistakes, because if these systems do not work well, your avatar within the VR space behaves strangely, and you can, let's say, move or skip from one place to another place too fast, and that can lead to sickness, which is not very well accepted here. And then I would say about a year ago came out devices which use inside-out tracking. So what's the difference between these ones and these ones? In this case, we need external sensors. We need external devices, which in combination with the headset can provide accurate and low latency tracking of the headset. But in this case, everything is included in the headset itself. So using the cameras, the headsets can track the movement of the player as well as the movement of controllers without any additional external devices. The advantage of this approach is that almost no setup and initialization is necessary. But maybe a disadvantage is that some occlusions can occur. For example, if you put one of your controllers behind your back, the cameras cannot see you and the movement is not precise, or and the experience degrades. Some key, let's say, key examples of this this technology, it has been integrated, for example, into Vive Cosmos or Oculus S and Quest 1 or 2 and Windows mixed reality headsets. So maybe the most famous ones would be, I would say, Oculus Quest 2 at the moment. What's also important is image quality. So when we first think of VR headset, of course, we think about image quality, and the resolutions have grown significantly within the few last years from, let's say, 1 million pixels per eye to several million. Here is a short table. And at the moment, I think we're about 2 to 2.5 million per eye, which is quite a lot. It's not perfect, but it's quite good, and the image quality provides good user experience. What's also important here is refresh rate. So how many times per second the image is changed and refreshed. And in case of VR, this is really, really important, and it's much higher than in case of typical desktop monitors. It often reaches more than 100 and usually also, I would say, 120 hertz or more. And the typical desktop monitor has 60 hertz. Why so high refresh rates? The main reason is latency and avoidance of VR sickness effects, because 60 hertz is not enough. And if we use this refresh rate, users tend to get sick. We need higher responsiveness of VR systems. What's also important is field of view. So how big a field of view is. And in the current generation, we are about 100 degrees. This is about, I would say, half of the usual human field of view, but we also have devices, for example, Pimax or Star VR, which reach almost the full field of view of the user of human vision. And these devices are mostly meant for industrial use. So it's very unusual to get them in Big Bang, for example. But also here, the next generation will have a higher field of view, maybe about 130 or maybe 150 degrees wide. And then we come to the, let's say, the question of pixels, right? So the higher resolution, the smaller the display, better image quality. The bigger display, less pixels lead to a more, let's say, pixelated picture. It's called the screen door effect. You can see it if you look closely at the image from a projector, you see some pixels. And with higher resolutions and especially image density, this effect is being lessened and lessened. And at the moment, let's say the most sophisticated devices are from Pimax and Star VR, which offer nearly 8K image quality. So, for example, if you look at the best television sets in the stores and you miniaturize them to the headset to this size, you can imagine how this would look like. But still, it's not perfect. It's not perfect. There's another example. It's a headset from Vario. They have VR1 and VR2 headsets, which are really clever in design. because they use a combination of two screens, one super dense screen, which allows for more than 3,000 pixels per inch. This is really, really high. This is, for example, more than 6 times more than a typical retina screen from the iPhone. And they use a bigger screen for peripheral vision. And they combine these two screens using eye tracking technology, which tracks the movement of eyes of the users and superimpose this super quality image upon this lower quality image. Yeah, and this device, this headset is mainly used and meant for industry applications. So it's not meant for consumer use, it's meant for industrial use. And I think here is, let's say, a comparison what would you see on a typical consumer VR headset, or what you would see on, let me change the times. Okay, what you would see on this this headset. As you can see, the picture is much clearer and, let's say, usable even for industrial simulations. Another technology I would like to emphasize is so-called varifocal display. So what the idea here is, the idea is that not only pixel image quality is improved, but also the true depth of field is shown. Because what's the problem with current devices is that the depth perception is the same regardless where you look in the virtual environment, and this is in a way bad for your eyes because the eye strain can be apparent for prolonged use. And in this case, the depth of field is not only simulated, but it's actually reached by a combination of lenses. And in this way, your eyes can adapt to the real, let's say, true depth in the field, in the image regarding the object you're looking at. So this would in a way lead to more natural perception and usage of VR. And this technology is being developed by Oculus and is expected to come in the next generation of Oculus Rift devices. On the other hand, we have augmented reality and mixed reality devices. Basically, I would only talk about two devices which have significantly marked this field. One is Microsoft HoloLens 1 and 2 devices, and the other one is Magic Leap. Both of them are very much advanced. They are useful, although they have some disadvantages. For example, the biggest disadvantage of mixed reality headsets compared to VR is that the field of view is really narrow. It's about 50 degrees or so. It's just like if you would watch outside through a small window, maybe like this. But otherwise, with this, these devices can, let's say, magically conjure up digital objects that are aware and can be placed within the real environment, and you can explore them like any other real object. And this can lead to numerous of interesting applications, mainly for the industry. At the end, I'll also show some of our examples how we use this technology. It needs to be said that commercial-wise, Magic Leap company has a bit of problems at the moment, although their device, I think, is, let's say, better than HoloLens. But we'll see what happens. Also worth mentioning is Leap Motion North Star project, which is freely available here and can be created and at home. And what's interesting here is that simple and cost-effective, really low-cost off-the-shelf components can be used, like screens from mobile phones and Leap Motion device for hand detection and some clever electronics. And in this way, you can have this experience. You can have mixed reality experience, and the main advantage compared to HoloLens and Magic Leap is that the field of view in this case is much larger. It's comparable to VR headsets, so it's in a way a bit a hacking project. Also, we cannot forgo mobile devices because augmented and mixed realities can be explored even now, using normal and simple mobile phones and tablets. And for example, projects created within UNI.MINDS, Euphoria, and WebXR platforms can be used for this. And thus, digital objects can be shown in real environment and explored by a simple and completely ordinary mobile phone. So this is also very much suitable for maybe education, for augmented printed material. Then what is needed for all this experience is the question. So for the best experience with VR, a VR headset is needed, a good VR headset, maybe Oculus Rift, maybe Index Valve, and also a high performance PC is needed because the resolution is really high and also refresh rates are very high. So basically a gaming computer is needed in order to provide good experience. For game console VR, like PlayStation VR, there's only one example, it's PlayStation and PlayStation VR, and also provides good experience and it's very much affordable. And on the other hand, we have mobile phones, and which can be used either in a case, in a cardboard or plastic case, or just standalone. And you can through the integrated camera, you can explore digital objects. And then also this, let's say, group of devices is getting more and more attention. There are standalone devices like Oculus Quest, and they offer untethered experiences whenever you are. So maybe the trend, I would say, is here. Also, Facebook is putting more research and commercial attention to these devices than to their tethered devices. So this would be a short overview of the VR and AR landscape seen as devices. What's also important are interactions, because these are the key for using these devices, basically. And there are several interaction modalities, basically means of interaction, from traditional keyboard and mouse and touch and gestures. And gestures can be also full body gestures without any controllers or just with hands. Voice is a good interaction modality. Also eye tracking. So with movements of your eyes, you can move around in VR. And tangible interfaces are special kind of interfaces where, for example, real objects can be used to access digital functions. For example, if you have a cube here, this cube can be a volume up button or maybe some other function, but you can also feel it. So here, different modalities, for example, touch and feel are combined with visual and auditory modalities. Maybe most, let's say, futuristic ones are brain-computer interfaces, where just with the power of your mind, in a way, you can control your avatar. And this is also not completely science fiction. For example, Neuralink from Elon Musk, they are developing revolutionary technology that would enable us to control our computers with our minds only. So this is maybe the most advanced and most futuristic way of interactions. But within the VR, these strange devices are most commonly used. They're called VR controllers, touch controllers, and these controllers can be very precisely tracked within the real environment and can be shown as almost anything in the virtual one, for example, as hands or tools or whatever is needed for specific applications. What is needed is a sense of touch, and also this is the next big thing that is coming. And for example, this device, desktop, allows also touch and feel, and allows the feeling of pressure of virtual objects in the real environment. So basically, you can squeeze or you can grab virtual objects, and this, in combination with good picture and good sound, allow for a very much immersive experience. Let's see a short video. course, as with any VR and AR technologies, this also touch technologies must be experienced. They cannot be conveyed through video or audio or presentations. This must be experienced. But I think this is the next modality that is coming out to a broad audience, and I think it will be available in the next few years, I think, or even sooner. And then the last component that is needed for a good experience is content and applications. And here we have like two different kinds of content, one for virtual reality and one for augmented and mixed reality. And within those two groups, two kinds of content is produced. One is real content, so pictures and videos in full 3D view. So this is often referred to as 360 video or omnidirectional video or panoramic video, where one can see all around, not only a small piece of the screen, but everything around the user. And the other one, the other kind of content is completely digital. It's completely 3D and computer generated. And this can be, with this, anything can be actually shown. You can explore a body from within and see how your body works, for example, which would be normally impossible. But in any case, interactivity is very, very much important also in these two cases. So on the other hand, on one hand, interactivity, on the other hand, good content and applications make good user experience within VR and AR. Just a short, let's say, some key insights with panoramic video, which are important. Here is an infographic of VR ecosystem providing 360 videos. On one hand, we have production. So we have only one camera is not enough. Usually these cameras have a lot of lenses in order to capture the whole scene from every angle. And also in 3D, you can see in stereo, so you can see 3D within these videos. Then distribution is important, so how this video is then transferred to your device, and also the quality of the end VR device is important, and all this influences the user experience. What's interesting here is that even though the, let's say, resolution of this panoramic videos is high, it's often 4K, so or more, the actual experience is not that great. Why? Because what you see is only a small portion of the whole video captured. And for example, if we want to have really great experience, let's say 4K experience within our viewport, we would need a much bigger captured video of the whole image. Much bigger means like 12K or more. And this implies great stress on computer power and also transmission and quality of service requirements of the network. So, and for example, bandwidth requirements can get really, really high. It's not uncommon they reach several hundreds or even gigabits per second. And also latency, so the delay should be small, 20 milliseconds or less. And this is at the moment really exciting research field, how to make networks that are capable of really good 360 video transmission and reproduction. Now, for some examples of applications, mostly I will show what we do through our industrial cooperation and also diplomas. And in a way, I think XR technologies can be used in many areas. I would point out education, also work, and also communications. This, in a way, Zoom is in a way VR could be also experienced in VR, in 3D environment, and also applications are at the moment available for this. What else? Who can profit from this? I think medicine, for example, doctors can get a much better idea how to maybe operate some difficult cases if they experienced it in first person rather just on the screen, and this can save lives. And also other fields can benefit from these technologies, I think. Anyone still, let's say, remembering Pokemon Go? It was really famous application which can be still seen on screens of some users nowadays, but this only, let's say, just opened the Pandora's box of the capabilities and extent of augmented reality. It was a really basic application. Why I'm showing it here today is because at the peak, this was played by millions of users all around the world, and it was a really most basic application of AR technology. What we're having now is much better than this and will be better. Now for some examples, how we use this. For example, here is an application for Parkinson's disease rehabilitation, which was implemented and is used within the rehabilitation center Socha. And we used two devices. We used VR Oculus Rift for first-person interaction with these objects. And we used lip motion device, which enables hand gesture recognition and movement without anything, without any controllers. And with this, we made a simple game which can be used for rehabilitation of Parkinson's disease and also for, in a way, accurate measurement of improvement and also personalization of tasks. And this technology, although it's off the shelf and commercial, it's very cheap and actually improves the conditions and the quality of treatment. And I think this is a good example how these technologies can be used for good purposes. Another case would be...
Jože,
yeah.
Jože, just a short intro.
Yeah.
We are quite running out of time.
I know, I need 3 minutes.
So maybe if you can speed it up, and so we have time for the questions.
We have questions. I would just like to... I'll speed it up. Yeah, I know. Yeah, sure. Yeah. So... to speed it up, another case I would like to show you is so-called digital twin. It's actually a recreation of a real environment within lake, and it was used to train new employees before they even set foot on the premises, and the results that we got are really good. So with this simple application, simple rendering, the new employees got enough experience in order to get better acquainted within the real laboratory, and also the, let's say, training time was very much shortened compared to traditional methods. And this is so digital twins are a really good example of industrial-based VR applications. Maybe another one is just this one is mixed reality football, which was developed for Sportradar. And in this case, here you can see with HoloLens device, if you put it on, you would see a normal TV screen, a football match, but also enhanced with additional information. So what the advantage here is that you are not immersed in a virtual world, but you are in a real environment and can also interact with your other colleagues and friends, but see additional information and interact with this information. Now for some promised trends and challenges, I would say there are a few. For trends, I would say everything, more of everything. So better resolution, better frame rate, and better displays. Another trend is no wires, so freedom of movement. And another one is eye tracking devices.
Jože, we cannot see your presentation.
Ah, okay. Sorry. Okay. Can you see it now?
Yes, we do.
Great. Okay, so as I was saying, trends, I would say better screen quality. So more pixels and less pixelated picture. That means higher resolutions. And then without computers, no wires. This is important. Eye tracking is important for interaction. So just with the movement of your eyes, you can interact with the virtual environment. And then also the mixing of VR and AR. So you can achieve VR experience within AR and vice versa. New interactions and touch, so you can feel your objects. And of course, social multiplayer. So you're not alone, you can interact in the VR space with your friends and colleagues. And the last one, or Semi-last one is web technology, so nothing needs to be installed. Everything is done by browser. And content is the most important challenge and trend which must be provided in order to provide something useful. There are still challenges, I would say. One of them is medical effects and specifically social and VR sickness effects. New, let's say, UX design is needed and research is needed. And VR sickness is, I think, the most difficult challenge in this case, because as the term implies, users really get sick. They throw up if the things are not done correctly. And content and apps are absolutely important. I would say this here, like that VR is like the first iPhone. A small number of people are extremely excited about it, but its true power still hasn't been created. You can exchange this iPhone for the XR in this case, and I think this is the state that we are at the moment here. Yeah, okay, just to conclude with this, I'll just skip. The future, I would say, I think there are two different kinds of development that we can see. One is the holodeck. So basically, with devices, we create our virtual environment that simulates everything. And on the other hand, we have the matrix. So with brain-computer interfaces, maybe we can simulate the virtual environment within our brains directly. I don't know. At the moment, we're getting into this direction, I think. But who knows what the future brings. Yeah, this is a short conclusion, a word cloud of these presentations. We were talking about XR devices, videos, reality, trends. And last but not least, this is what I wouldn't like that this technology would turn into. So the social disparity and a bunch of people looking into their VR headsets, and Mark Zuckerberg is walking just by them, and they would actually kill to get the opportunity to shake hands with him, probably. I don't know. So this, I think, is the wrong future. And yeah, with this, I would like to give the word back to the studio, and thank you for your attention and patience.
Thank you, Jože, for this interesting snapshot of what future brings. Let's try to quickly answer some questions. Urshka is asking how you work, if you have worked also with Snapchat glasses, and she also posted here a link, if you can check. Maybe you can quickly reply that.
Sorry, what?
Okay. Urshka is asking about Snapchat glasses, if you worked with them, and if you probably she has
not. I haven't had the opportunity to use the Snapchat glasses yet.
Okay, and then Igor is asking if you can connect with eye tracking glasses, for instance, Vario XR1 or Vive Pro Eye.
If you can what?
If you can connect eye tracking glasses.
Yeah.
If you can connect this.
Yeah, if I get this correctly, so both devices that are mentioned here, Vario XR1 and XR2 and Vive Pro Eye and some other devices have integrated eye tracking, and mainly for the purpose of providing, let's say, real depth of view, because the rendering in this case is like that the headset determines where the user is looking at, and that area is rendered in, let's say, greater detail and greater quality than the rest of it. And in this way, VR sickness is reduced. That's how the eye tracking is used within these devices. Another use of eye tracking systems within VR is for research purposes, for, let's say, attention and focus research, where the user is looking at and how they are interacting. If I got this question correctly.
I think yes, otherwise, Igor, you can ask again. Yeah. And okay, he says, thank you. Darko is asking which smart city solution can be implemented or can profit from XR?
Yeah, a very good question. I would say at the moment, there's a real battle for content, and also, for example, whole cities, whole landscapes are being digitized. For example, if you imagine Google or Google Earth or Google Maps, you have a flat or also 3D image of the real environment. But now imagine that you have, like, in best detail, a digital representation of maybe Ljubljana, and you have like this augmented reality glasses, and you are walking on your street, and the most simple application would be, for example, navigation, but also other kinds could be used. For example, if you are in emergency, you can see direct route to maybe some medical devices or safe zones, or of course there's a more commercial end to this. There are ads, and the idea is that if you've seen Minority Report, when Tom Cruise was walking on the street, the personalized and let's say automatic ads were shown to him for some discounts and stuff. So this is in a way smart city. Can be good, can be bad use. Another case would be in combination with 5G, because one of the key, let's say, cases is VR within cars, for within automated cars, for media consumption in 3D, for panoramic video. An interesting case. So yeah, maybe this would be an answer.
Okay, thank you, Jože. Urška is commenting that, well, she recommends to try Snap as well.
Okay, cool.
Okay, so, I think you now answer all the questions. Thank you for this. And if there is some other questions, someone can also probably unmute and ask live if there is still some question. Otherwise, I can.
Jana, Urška asked another question. It's a long text.
Okay.
Can I read it if I have it here? We see that more and more customers would like to order personalized videos. We would like to pick up text from a database and generate a video from it. And if we could add to that also another dimension, so that this would be read from a person's lips, this would be even more personalized. Some kind of deep fakes, but in a sense of bringing text to speech.
So just let me get the chat.
Do you have it?
Yeah, I can see. I'm reading the question. Okay. So if I understand correctly, you would like to use so you would like to create videos, like fake videos with the text from the database, and which should be also lip synced, right? This can be done. This can be done with, let's say, normal home desktop computers. For example, a good example of this technology can be seen on SIGGRAPH conferences, and yeah, this is possible. Yeah. You can make good
Thank you for
it. Yeah.
Super, thanks. Didn't know that.
I'm not sure this is a good
okay.
This is what we want to have, but it's possible. Yeah.
Okay, thank you.
Yeah.
Great talk. Thanks, guys.
So we came to the end of this workshop. Thank you, Jože, and we can continue the discussion in Whova application. The link will be posted in chat, so if you have questions, you can post them then. You can create meetups and also place some articles, and a discussion can start. So please be welcome to use it. And yeah, also you can rate this session in the Whova app. We will be very grateful because it will help us to do even better in the next time. Also, I have to mention that this event was organized by Knowledge Transfer Office of University of Ljubljana and University of Maribor. And we have to thank all our sponsors as well. And I also have to mention that this event wouldn't be possible without the co-financing of Republic of Slovenia and the European Union under the European Regional Development Fund. So I really hoped you enjoyed this workshop. Thank you, Joža, for really great insights and also answering all the questions and issues that were raised up. You're more than welcome to attend our next event during next week. Check this schedule. It's quite a full agenda, lots of interesting topics, and feel free to join us at the events that you feel more passionate about. So thank you for participation. And well, yeah, take care, have an open mind, and see you next time. Bye-bye.
Thank you.
Bye. Welcome. Bye-bye.
Bye.